the first thing to understand when you're talking about bilirubin, where does bilirubin even come from? Okay, so if we have some blood vessel here, so let's just say we have, some blood vessel here, and maybe we have some red blood cells traveling through this blood vessel. Now, these red blood cells, typically, their lifespan is going to be about 120 days in adults. Now, in neonates, this is going to be shorter, but in adults, these red blood cells will have a lifespan of about 120 days, and eventually they'll become senescent and have a difficult time making it through the red pulp of the spleen. They may be phagocytosed by macrophages. Okay, so splenic macrophages. This could happen in the bone marrow or the liver potentially, but the spleen is kind of the classic example. That's where the majority of these red blood cells will get broken down. Now, when these red blood cells get phagocytosed, remember, these red blood cells contain a lot of hemoglobin. Okay, so what's hemoglobin made up of? Well, it's really just, like the name implies, heme and globin, right? Now, these globin chains, these just get recycled, to be used as amino acids, but the heme is really interesting for us. This heme actually can get converted to a compound known as biliverdin, and this happens through the activity of an enzyme known as heme oxygenase. Okay, so heme oxygenase essentially converts the heme to biliverdin, and then in the macrophages, this biliverdin will then get converted into unconjugated bilirubin, and that's going to be a reduction reaction using biliverdin reductase. So I'm just going to put UCB here for unconjugated bilirubin, and this is really the important, compound here. The first really important thing to understand about unconjugated bilirubin is that this is going to be lipid soluble. Now, because this is lipid soluble, when this unconjugated bilirubin gets back into the bloodstream, it's usually going to be transported by proteins. Now, the classic protein that the unconjugated bilirubin will be transported by is going to be albumin. So you're going to have this unconjugated bilirubin albumin complex that's essentially moving through the bloodstream. And this was all a result of these senescent red blood cells that were phagocytosed by macrophages and then had the heme converted eventually into this unconjugated bilirubin. So that's really the first step of this pathway. So bilirubin production basically comes from the destruction of red blood cells that eventually will have heme converted to biliverdin via heme oxygenase, like we said, and the biliverdin is eventually then converted to unconjugated bilirubin via biliverdin reductase. That unconjugated bilirubin, like we just said, it's lipid soluble and it's going to be bound to albumin in the blood. If you've been following the video series so far, you might recall that, let's just say this senescent red blood cell goes through the red pulp of the spleen and is eventually phagocytosed, and heme is eventually converted to biliverdin and then eventually converted to this unconjugated bilirubin that's now bound to albumin because it's lipid soluble, right?